In this section, I'm going to talk about a counting technique called the addition principle. And basically, the addition principle says for any two sets A and B, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in their intersection. And the reason you have to subtract this intersection is because if you simply add the number of elements in A plus the number of elements in B, if there is an intersection, you actually would end up adding those elements twice. So that by taking the intersection away, that corrects it so that you only have those elements added once. Now, if A and B do not have an intersection, then you can simply just add the number of elements to A plus the number of elements to B. But remember, that's only if A and B do not intersect. Okay. There's another way to get the union once you draw the Venn diagram, but I'll show you that later. Now, from the sets above, let's say that we wanted to know the number of elements in A union B from our sets above that had all the different shapes. So remember right here you have the A has 4 elements and the set B has 4 elements, and then remember there's 2 elements in the intersection. A triangle and square are the 2 elements in the intersection. So therefore, using the addition principle, if you want to know the number of elements that's in A union B, you would add the 4 from set A, the 4 from set B, and then subtract the 2 from that's in the intersection and get 6. And here's your 6 elements if you want to check it and write them all out there. Okay, now if you go to A union C, if you want to find the number of elements in A union C, well, notice that A has 4 elements, C has 3 elements, and there's no intersection of the elements from A and C. So in that case, you can just take the number of elements in A and add them to the number of elements in C and get 4 plus 3, which is 7 elements. And again, you can list all 7 of the elements here to check it and see that there are 7 elements. Let's look at a playing card example. Consider a standard deck of 52 cards, and let's let the universal set be the set of all 52 cards. Now, let's say that A represents the set of all red cards, so that would be the ace of hearts, 2 of hearts, and so forth, and the ace of diamonds, 2 of diamonds, and 3 of diamonds, and so forth. Well, there's 26 red cards in a deck. And let's say that B represents all face cards. Well, the face cards are your jacks, queens, and kings, and there's 4 of each, so that would be 12 face cards in a deck. And let's say that C represents the set of all 2s in a deck, so there's 4 2s in a deck of cards. Now, if I want to find the number of A union B, I can use the addition principle, but remember, to do the addition principle, I have to know the number in the intersection. So let's go back up here and find the number in the intersection. Well, the number in the intersection would only be 6, because if you look at what's in the intersection of all the red cards intersected with all the face cards, that would just be the jack of hearts, the queen of hearts, and the king of hearts, and the jack of diamonds, queen of diamonds, and king of diamonds. So you can see that the number of elements in the intersection is 6. So now if you want to know the number in the union, all you have to do is take the number that's in set A, which is 26, plus the number in set B, which is 12, and then subtract the number in the union, the intersection, which is 6, and you get 32. Now, the 2 sets B and C, those that do not have an intersection, so the number in B intersects C would be 0, because B intersects C is the empty set. So in that case, since they don't intersect, the number in B union C would just be the number in B plus the number in C. So in this case, the number in B is 12, the number in C is 4, so that would be 16. And you can look at a Venn diagram down here and see this down here. See, there's 52 cards, so in this rectangle, you know there's 52 cards, and this first circle is your 26 red cards, in your second circle is your 12 face cards. Here where they overlap are the 6 that are both red cards and face cards, And then if you took the 6 away from 26, you would get 20 cards that are red cards and not face cards. And if you took the 6 away from 12, you would get that there's 6 cards that are not red cards and are face cards. And then if you take the 20, the 6, and the 6, which adds up to 32, and subtract it from the 52 total, then you have 20 cards that are outside the circles that are neither red cards nor are face cards. So anyway, the Venn diagram helps you, and once you have the Venn diagram drawn, you can pretty much answer any question about the number of cards that you're looking for here. Okay, in this next example, I have a class of 35 students where 19 are married and 20 are blonde, and I know that 7 are both married and blonde. And I've got some questions to answer, so let's just drop down here to the Venn diagram. So you know you have a total of 35. You know that if I let A be the married students and B be the blonde students, well, you know I have 19 married students, I have 20 blonde students, and I have 7 that are both married and blonde. So if I take 7 from 19, that gives me 12 that are married but not blonde. And if I take 7 from 20, that gives me 13 that are blonde but not married. And then if I add these together, I get a total of 32 accounted for. So that would leave me, if I take 35 minus those 32, that leaves me 3 out here that are neither married nor blonde. So once I got this filled out, I can answer all these questions. How many are married but not blonde? That's the 12. How many are blonde but not married? That's this 13. How many are blonde or married? Well, you can do this 2 ways. You can just add these, since these sets don't intersect now. 12 plus 7 plus 13, that accounts for everybody that's in sets A and B. So that's 32. Or you can do the addition principle where you add the number in A plus the number in B minus the number in the intersection. You'll still get 32. And then this one says how many are neither blonde nor married. That's these guys out here. And then this one says how many are not blonde. Well, since these are the blondes, you would have 12 here that are not blonde and 3 out here that are not blonde. So you'd have 15 that are not blonde. Okay, here's another example, pretty much the same concept. 500 businesses, 250 have copiers, 300 have fax machines, and 100 have both. So here's your 500. The first circle is 250 that have copiers. The second circle is the 300 that have fax machines. And you have 100 in the middle because there's 100 that have both. And so if you take 100 from 250, you have 150. That's the ones that only have the copiers but no fax machine. And then if you take the 100 from 300, that leaves you 200 that only have the fax machines but no copier. And if you add these up, they add up to 450. So 450 from 500 means that there's 50 that have neither a copier nor a fax machine. And then once you fill that out, you can answer the question, how many had one or the other? Well, that would you can just add these up to get 450, or you can use the addition principle where you say 250 plus 300 minus 100, and that'll also give you 450. How many had neither? Well, that's the 50 that's out here. How many had a copier but no fax machine? Well, that would be the 150 over here. How many had a fax machine but no copier? That's the 200 here. And how many had no fax machines? That would be the 150 plus the 50 out here. So here's 150 with no fax machine and the 50 more with no fax machines. So that's 200. All right, and then from the addition principle, I just want to show you something here. I'm giving you some information. There's 110 in the universal set. There's 50 in set A. There's 75 in set B. And there's 105 in the union. And it says find the number in the intersection. Well, you can get that easily by simply doing, where is my addition principle here? Okay. So the number in the intersection is 20. So we can solve that equation. Oh, I know what I was going to do. Sorry if I confused you there. We know this equation is true from the addition principle. So what I did is I just plugged in the 105 for the number in the union. I plugged in 50 for the number in A, 75 for the number in B, and then I just solved for the intersection. So I know that this is 105 and this is 125 minus the number in the intersection has to equal 105. So I can easily solve that and find that this has to be 20. So the number in the intersection has to be 20. And the others, you can just answer those, just do a Venn diagram. So I'll leave you to do a Venn diagram and answer these others, and you can check the work here. So you can do that as a practice problem. Pause the video here and go ahead and work practice problem 1 by drawing a Venn diagram. And then you can check your answers with the answers that I gave down here. And then when you're finished, you can go ahead and start the video again, and then you can move on to the next practice problem. And the next practice problem, this is actually a 3 Venn diagram problem. And so go ahead and read this one and then answer these questions here. And then when you're finished, go ahead and play the video again, and I'll show you the Venn diagram that goes along with this problem. Now I assume at this point you've already worked those 2 practice problems. So there's the Venn diagram that goes along with that last problem, and that pretty much ends the section on the addition principle. And the next section we'll cover is over the multiplication principle.